Hello beautiful people and welcome. In this video we are writing the equation of a quadratic function. Now these are given sketches to us of a quadratic function and we're going to write the equation for that. Before we begin, go ahead and take a moment to sketch this one out. So I'm going to go ahead and label these points for you so that way you can sketch them out. I have my vertex here. I'm going to do a little line of symmetry so you guys can see that. So that is at 1, 2, 3, and 3. I have a secondary and a tertiary point, so a second and third point here on my x-axis. One of them is located at positive 1, the other one is 2, 3, 4, and 5. When writing the equation of a quadratic function, you're going to start with the vertex form. So the vertex form is y equals, you can put f of x if you wish, a times x minus h squared plus k. So when we have that form, you have your x and y that kind of won't be touched in the very first step, but then you have your h and your k. Your h and your k is your vertex point. So here's your h, here's your k. Now remember, when you are writing out your equation, h is always opposite of what you see. So in this case, I see a 3, so therefore I am writing a minus 3 in here. K always stays the same, which in this case I see a 3 here, so K is going to be a positive 3. Now we need to figure out what our A value is. So when solving for A value, A is going to be solved for by using a different point. So choose another point. When choosing another point, choose the one that is a pretty point that is on the curve and gives you a good input and output. For example, I'm going to choose this point here, which gives me a x value of 1 and a y value of 0. So here's my point. I'm going to label this x and y. I'm going to plug in, substitute for x and y in the equation, and then I'm going to solve. You're going to solve for your a value. So how does that look like? I'm going to switch colors here. So I have y equals a times x minus 3 plus 3 right now, squared. I forgot my squared here. So now I'm going to put in 0 for y, and I'm going to replace x with 1. So then that means I'm going to evaluate a times something squared. So 1 minus 3, that is a negative 2. Negative 2 squared is 4. 4 times a, again, don't add yet. 4 times a is 4a. We have a plus 3 here. Here's a 0. And I'm going to shift this up here because I'm running out of space. So I have 0 is equal to 4a plus 3. I'm going to subtract 3 both sides. So I have a negative 3 is equal to 4 times a, divide by 4, divide by 4. A is now equal to a negative 3/4. Now it does make sense that this would be a negative because we have a decreasing function, a frowny face, and our arrows are pointing down. So we're going to go back up here to our step number 1. I'm going to remove the a because we already know what a is. And I'm going to input our a value of negative 3/4. And this would be your equation in vertex form. Now, if you wanted to do this in standard form, we would multiply it out. I am noticing, however, that we can do this in a different form. And the form that we can do this equation in is your intercept form. So this one here was the vertex form. And I'm noticing we can do this in intercept form because I know what my x-intercepts are. We know what our x-intercepts are, it's gold. So the format for the intercept form is y equals a times x minus p times x minus q. Now again, if it's inside parentheses, it's opposite of what we see. So our first x-intercept was 1, 0. Our second x-intercept is 5, 0. So here are the zeros, the x values. So I'm going to replace p and I'm going to replace q with the opposite of the numbers that I see. So if I see a 1, I'm going to write minus 1. If I see a 5, I'm going to write minus 5. So now I have my two bubbles. So now I have used these 2 points. I'm going to now use the third point, which in this case is our vertex, our 3, 3, as my third point. I'm going to label this x and y, and I'm going to replace y with 3, and I'm going to replace x with 3. So I have 3 is equal to a times 3 minus 1 times 3 minus 5. And I'm going to solve and evaluate for the value of a. I'm going to shift this up. So I have 3 is equal to a times 3 minus 1 is 2. 3 minus 5 is negative 2. So 3 is equal to a times negative 4. I'm going to rewrite this as negative 4 times a just because it makes me feel better. I'm going to divide by negative 4, divide by negative 4. So a is equal to negative 3/4. Now the a value, if you looked for the vertex form and the intercept form, ended up being the same thing, a negative 3/4. And that's okay, that's good. It should be the same because we have the same quadratic function. So I'm going to bring this back up here and I'm going to remove my a because we know what a is. And our a was a negative 3/4. And now there is our intercept form of the quadratic equation.